In this video we learn about irrational numbers. Irrational numbers. What are irrational numbers? Numbers which cannot be written, numbers which cannot be written, which cannot be written in the form of p by q not equal to 0, pq are integers, are known as irrational numbers. For example, square root of 2, square root of 3, square root of 5, they all are examples of irrational numbers. In the above example, we have given root 2 as an irrational number, root 3 also as an irrational number, root 5 as an irrational number. Now let us try to prove that root 2 is an irrational number. So here we will prove that. First example we will take, prove that root 2, square root of 2 is an irrational number, Now solution for this or proof for this, we will prove that root 2 is a irrational number by the method of contradiction. So this is known as method of contradiction. So what we'll do basically is that we'll take opposite of irrational. Opposite of irrational is rational. So let us take, let if possible root 2, square root of 2 be a rational number. Therefore, root 2 equal to p over q. Q is not equal to 0. PQ are integers. And SCF of PQ is equal to 1. So this is very important condition, because whenever we are writing any fraction, we write it in the least form, the simplest form. Therefore, unless you write that SCF of PQ is 1, your proof will remain incomplete. So do not forget to write that SCF of PQ is 1. Now so what we are having here is root 2 equal to p by q. Squaring, that is, let us say that this is again, so here root 2 equal to p by q. Give it equation number 1. Squaring both sides, we have squaring both sides. So what we will have is square root of 2. If you take the square, we will get 2. 2 equal to p square by q square. This will implies give us 2q square equal to p square. Therefore, q square equal to p square by 2. Now, therefore, 2 divides p square. This is the symbol for divides. This is not 2 by p square. This is the symbol. So you have to make a straight line. So it becomes 2 divides p square. Therefore, 2 divides p. There is a theorem in the number system that when a number divides the square of any number and that number is prime, suppose here 2 is a prime, so that prime number will divide the number also. So this is how we have got. So since 2 is dividing p, so we can write p will be multiple of 2. So therefore we can say that p is equal to say 2m. So give it equation number 2. Now let us put this in putting 2 in. See here, we'll recall what we have written earlier. Here we have written this one, q square equal to p square by 2. So let us substitute the value of 2 in, suppose let this be 2 and this will take it 3. So put 3 in 2. Put 3 in 2. Whatever, what is our 2? 2 is q square equal to p square by 2. So therefore, putting 3 in 2, so q square equal to p square by 2. What is p? Our 2m. 2m whole square by 2. See here again. What is our q square? P square by 2. So I have replaced p with the value of p, that is 2m. 2m by 2 whole square. Therefore, we are getting q square equal to 4m square by 2. Therefore, we can say that q square is equal to 2m square. Therefore, we can say that m square is equal to q square by 2. Therefore, again, therefore 2 divides q square. Now again we can see here that 2 is a prime number and it is dividing the square of q. Therefore 2 will also divide the number q. Why? Because of the property which I told you. There is one theorem in number system that if a prime number divides the square of any number, then that prime number will divide the number also. So since 2 is dividing q, therefore q has to be a multiple of 2. Therefore q equal to 2n. So let us keep it as 4. Now you can see from this our 3, 2m. P is equal to 2m and here q is 2n. From 3 and 4. From 3 and 4 we have common factor of p and q is 2. We are not saying that it is the SCF, but the common factor of, you can see that q equal to 2 into n and here p equal to 2 into m. So this is a contradiction. Why it is contradiction? I'll show you again. Here, what we have written was that the SCF of PQ is 1, but what we are getting is as a common factor is 2. Common factor can never be greater than the SCF. Therefore, there is a contradiction. That means what we have assumed, that is false. So what we'll write from 3 and 4, we have common factor of P and Q is 2, but SCF of PQ equal to 1. Therefore, our assumption is false. Therefore, our assumption is false. And therefore, what we have assumed that root 2 is rational. Therefore, root 2 is irrational. So this is how we'll get the proof. Now in the same way we can write the proof of root 3, root 5 and so on. I'll show you how we can write the proof of root 3. Suppose in place of proof that root 3 is an irrational number, the question is prove that root 3 is an irrational number. Prove that square root of 3 is an irrational number. So wherever we have written root 2, we are going to replace that with root 3. So here in place of 2, we have written here 3. Similarly here, let if possible root 2. So we write it as root 3, square root of 3. Now again, here also we have written root 2. So replace that with root 3. And suppose they ask you about root 5, square root of 5. So just replace this number with root 5. So remaining all will remain same. Therefore root 3 equal to P by Q. Q is not equal to 0, P, Q are integers, and SCF of PQ equal to 1. Let root 3. So again we will write here root 3. So square root of root 3 equal to P by Q. Now squaring both sides, square root of 3 will become 3. So we are going to get here 3 equal to P square by Q square. So this will give you 3Q square equal to P square, and Q square equal to P square by 3. So it's very simple. Replace 2 with 3, and similarly if it is square root of 5, you have to replace the number with 5. Now again we are having here 2. So because now a new number is 3, replace with 2 with 3. So it is 3P square. P square equal to 3M. So here, therefore 3 will divide P, because 3 is dividing P square and 3 is a prime number. So 3 will divide P. So we can write P as 3M. P equal to 3M. So Q square equal to, because replacing 2M, because wherever 2 is there we are replacing with 3. So what we are going to get here, Q square equal to 3M whole square divided by 3. So Q square equal to square of 3 is 9. 9M square by 3. So Q square equal to 3M square. M square equal to Q square by 3. So since M square equal to Q square by 3, so 3 will divide Q square. And 3 divides, this will give you 3 divides Q. Why? Because 3 is a prime number. So we can write Q equal to 3 into N. So what we have got from 3 and 4, we have common factors of P and Q is 3. Because you can see that here Q is equal to 3 into N, here P is 3 into M. So common factor is 3. As I told you, common factor can never be greater than the SCF. But what is the SCF? It is 1. Therefore, our assumption is false. Therefore, square root of 3 is irrational. Same way you can write the proof of root 5 also, square root of 5, square root of 7 and so on. Just replace the number in square root of 2, what proof we have taken, in that wherever 2 is there, replace. If we are writing the proof of square root of 3, replace with 3. If you are writing the square root of 5, replace with 5. And if it's 7, we are finding the proof of square root of 7, replace 2 with 7.